All right, so a student solved the equation x squared is equal to 132. Find the diagonal of a square in centimeters. What measurement is closest to x, the length of the diagonal of this square in centimeters? Whenever you get an equation like this and you have x raised to an exponent, the way to undo squaring something is to take the square root. So in this case, I'm going to take the square root of 132. So we're going to take the square root of 132. So with your calculator, you would be doing second x squared to get the square root sign, 132. So this becomes 11.489. And it says round to the nearest whole number. Okay, so when we look at the whole number, we're looking at the ones place. So I look at the tens place behind. 4 or less, let it rest. 5 or more, raise the score. Well, the tens place is 4 or less, so I'm going to leave it as 11 as my whole number. Number 2 says the table shows the completion times for runners in a race. List the runners from fastest to slowest. So fastest would be the person who completes a race in the least amount of time. So we would be going least to greatest. When you are putting things in order from least to greatest, you want to make sure that they're all decimals. So 12 and 1/2, well, I know 1/2 is a decimal of 0.5. And then I have 12.09. That was already a decimal. I'm going to add a 0 to that 0.5 so that it goes out to the same place value. Now we have 12 and 2/5. Well, if I do alpha y equals, the second option allows me to enter a mixed number. So I'm going to enter 12, use my right arrow key over. We have 2, and then fifths, so 12 and 2/5. And then if I go back to alpha y equals, this last option tells me we're going to switch between fraction and decimal. When I do that, it gives me the decimal form. So 12.4, I'm going to add a 0, keep it all in the same place value. And then I have 12.80. We're all going out to the hundredths place. Well, least to greatest, if we look at the tenths place, this one here has a 0, so this is the smallest. So we're going to say Ellen is the fastest because she had the least amount of time. Next, still looking in the tenths place, I have a 4, so then we have Steve. Then we have the 5, which would be Joe, and Patty is going to bring up the end of the race. All right, number 3, Ellis shows the numbers in order from greatest to least is shown below. What could be the missing number? Well, the missing number, I'm going to need to change the square root of 17 into a decimal. So we're going to do second x squared. We have 17. So this is roughly, we have 4.123. So I need something in between 4.123 and 371. Well, 4.5 is out. Now, 3.8%, to change a percent to a decimal, we're going to do the Dr. Pepper method. I'm starting at a percent, so I'm going to move my decimal place 2 places to the left. So we have 3.8%, 2 places to the left. That's 0.038. So that would not fit between 4.123 and 3.71. So B is out. To make a fraction a decimal, you simply are going to divide. So we're going to do 57 divided by 15. Which is 3.8. Well, 3.8 would fit between the 4 and the 3.71. So that seems like a good option. I'm going to check D out just to be sure. I'm going to type it exactly as it is written. So parentheses 3.9, and then we're going to do our squared. So to get an exponent, you're going to use this caret button that's underneath clear. Squared, that is 15 and 21 hundredths. Well, C is the best option because it fits between those. Number 4 says the mass of a textbook is approximately 0.00165 metric tons. How is this number written in scientific notation? When we write numbers in scientific notation, this is going to be our format. We're going to have one number in front of the decimal with some numbers after the decimal point times 10 to something. So we're going to start. I need to move my decimal so there is one number in front of the decimal. So I want it to end up here after the 1. So I move it 1, 2 times. 1, 2, 3, 1, 2, 3 times. So my exponent here is going to be a 3. The number in front of the decimal is the 1. We're going to put our significant digits behind, so I'm going to put my 6-5. And then the final question you have to ask yourself, was the number originally large or small? Well, the number was originally really small, so this is going to be a negative exponent. Same thing with number 5, we're just doing scientific notation again. So same setup, we have a number in front of the decimal, some numbers after it, times 10 to an exponent. So this time when I'm starting out, I have 463,100 books. If the decimal is out of sight, it's to the right, so I'm going to put my decimal point on the end. I want one number in front of the decimal, so I want it to end up behind the 4. So I'm going to move it 1, 2, 3, 4, 5 times. So 5 is my exponent. The 4 ends up in front of the decimal. We're only going to keep our significant digits. Remember, significant digits are numbers that are not 0 or 0 if it's between two numbers that are not 0. So in this case, I'm just going to keep the 6, 3, and the 1. And then I need to ask myself, was this a really large number or small number to begin with? Well, 463,100 is a large number, so that exponent is positive. Point Q is shown on the number line. Which value best represents point Q? Okay, so there's a mark between the 5 and the 6. So I'm going to say this is 5.5. And then we have Q there. So we want to see which one is closest to 5.5 out of our answer choices here. Trying to get it so there's no glare. So we're going to do the square root of 5.4 to do a square root, second x squared, and then we're going to enter 5.4. Well, that becomes 2.3 something, so that's not close to 5.5. We can do the square root of 29.5, so second x squared, 29.5. Oh, that's about 5.4. I would say this is pretty close to where we're going to go. Pretty close to the 5.5, but we'll keep going to check. So we'll do second x squared, 35.5. Oops, try that one again. Second x squared, 35.5. That's about 5.9, so I'd say that should be closer to the 6 than it is here. And then again, we have the square root of 5.9, so second x squared, 5.9. Again, that's back in the 2, so our best answer choice here was B. All right, number 7. Set Q and set Z are subsets of the real number system. Q are the rational numbers and Z are the integers. Which Venn diagram best represents the relationship between set Q and Z? Okay, well, first off, B and D should be immediately out because we know that the way these are set up, that these are supposed to be circles inside of each other. We've drawn this Venn diagram several times. So now the question is, do the rational numbers go inside the integers or do the integers go inside the rational numbers? Well, the rational numbers includes fractions and decimals, but the integers does not. So the integers needs to go inside the rational. So I'm looking for Z inside Q, which is C. Number 8 says the diagonals of 3 rectangles are shown below. Which rectangle has the longest diagonal? Again, we're comparing things from greatest to least. So I'm just going to make them all decimals. This one is already a decimal. To change a fraction to a decimal in the calculator, you are just going to divide. So we have 34 divided by 5. That gets me 6.8. And then the last one, we have the square root of 36.5. So second x squared, 36.5. Which is 6.04. If I just look at the tenths place, this is a 7, this is an 8, this is a 0, rectangle S is the longest diagonal. Ordering the following numbers from greatest to least. So we're going to make them all decimals. So square root of 38, we're going to do second x squared, and then we're going to type in 38. So this is 6.16. We have negative 6.35. To change a percent to a decimal, we're going to use the Dr. Pepper method. Starting as a percent, move it 2 places to the left. I can't see the decimal. If it's out of sight, it's to the right. 2 places left, so this is 0.63. And then we have negative 19 thirds. Again, I'm just going to divide to get it in the calculator. So this is negative 6.3 repeating. That's going to go on forever. When we are ordering from least to greatest, the negatives will always be the smallest numbers. And remember, when you're thinking negatives, you want further away from 0. So negative 6.35 is actually going to be further away from 0 on a number line than negative 6.3 repeating. So the smallest here is negative 6.35, followed by our other negative, which is negative 19 thirds. And then this one has a 6 in the ones place, this has a 0, so 63% would come next. And then our square root of 38. Number 10 says, how is the area of a piece of land is 4,951,000 square meters. How is this number written in scientific notation? Same thing, scientific notation, you start with this format, a number in front of the decimal, some numbers after it, and times 10 to an exponent. So this time the decimal is out of sight, so it's starting to the right. I want it to end up with only one number in front of the decimal. That number is going to be the 4. So I'm going to move it from the end 1, 2, 3, 4, 5, 6 times. 1, 2, 3, 4, 5, 6. So my exponent is a 6. The 4 is in front of the decimal. I'm going to keep my significant digits, which are those numbers that aren't zeros, so 9, 5, 1. From the beginning, this number was a really large number, so my exponent stays positive. Okay, that's Wildcat Sheet 2. Wildcat Sheet 3, this one says the area of a square wall is 182 square feet. What is the closest to the side length of the wall? Round your area to the nearest tenth. Okay, when I give you the area measurement to find the side length, you must take the square root. When you are given the area of a square, you need to take the square root to find the side length. So for this problem, we're just going to be doing the square root of 182. You got your calculator for that. So second x squared, 182. This is 13.490. We are rounding to the tenths place, so that's one place after the decimal. I look to the hundredths place to decide what I'm going to do. If it's 4 or less, we're going to let it rest. 5 or more, raise the score. This 9 tells me to bump the 4 up, so this is 13.5. You must be able to round. If you cannot round, I will mark these wrong. Number 2, the table describes two dilations with the center of the dilation at the origin. Write a rule that describes dilations. Okay, dilate means to multiply. So when we write our rules, we always start with x, y. And then for dilations, we're multiplying. So some number times x, some number times y. And that number is just going to be your scale factor. So here we have a scale factor of 1/2. So our rule starts out x, y becomes 1/2 x, 1/2 y. This question required no actual math, just your understanding that dilate means to multiply. This one, we have a square dilated by a scale factor of 2. So we have xy becomes 2x, 2y. Number 3, trapezoid KLMN is reflected over the x-axis to form trapezoid WXYZ. Which statement is true? If I am talking about a reflection, these shapes are congruent. The only transformation that changes the size is going to be a dilation. So A, the area of trapezoid KLM is greater than the area of trapezoid WXYZ. Well, if they're congruent, the size isn't changing, so their areas are not changing. So A doesn't make any sense. B, the angle measures of trapezoid KLM are less than the corresponding angle measures of trapezoid WXYZ. Well, what we have learned is that angles are always congruent. Even when we have a dilation, which is changing the size, the angles never change. So B doesn't make sense. The sum of the angle measures of trapezoid KLMN is twice the sum of the angle measures of trapezoid WXYZ. Well, again, this is telling us that the angles are changing. Nope. The side lengths are congruent. Absolutely, we do not change size, so the side lengths are going to stay congruent. Following numbers in order from least to greatest. I'm going to put them in the calculator and make them all decimals first. So the first thing I'm going to do is we have 5 halves, so we're going to do 5 divided by 2. Which is 2.5. This one is already a decimal, negative 0.43, negative 43 hundredths. Square root of 3, we're going to do second x squared for 3. And I have 1.73. And then negative 4 divided by 3 gives me negative 1.3. Okay, when we are putting things in order from least to greatest, our negatives are going to come first. And again, we're talking about further away from 0. So this one, -4/3, is further away from 0, so that would be smaller. Then we'll put our other negative, -43/100. Then we have a 2.5 and a 1.73, so the square root of 3 is now smaller, and then we close it up with 5/2. Number 5, the density of oxygen is 1 and 429 thousandths times 10 to the -3 grams per cubic centimeter. How is this number written in standard form? So when we write in standard form, we're going to move the decimal point dependent on the exponent. That exponent is negative, so I'm going to move my decimal to the left. So I'm going to go 1, 2, 3 places to the left, and we're going to fill in with zeros. So we should have 2 zeros in front of that number. Number 6, Jacob notices that a tree shadow is 24 feet long. If he stands in front of the tree, his shadow is 4 feet long. If Jacob is 5 feet tall, how tall is the tree? I'm going to draw a picture. I highly, highly, highly encourage you to draw a picture. There's my tree. There's the shadow. We have Jacob. Here's his shadow. Well, the tree shadow is 24 feet. Jacob's shadow is 4 feet, and he is 5 feet tall. So I do not know how tall the tree is. So we're going to set up a proportion. So x, the height of the tree, matches Jacob's height, which is 5. Then we have 24, which is the tree's shadow, matches Jacob's shadow, which is 4. I'm going to cross multiply, so I'm going to do 24 times 5, which is 120, but let's just double check. So 5 times 24 indeed is 120. So 120 is equal to 4x. So I'm going to divide both sides by 4. So we have 30. The tree is 30 feet tall. Okay, on the back, our final 4 questions. Number 7 says, rotate the triangle 270 degrees counterclockwise, then state the ordered pair for y prime. So when we rotate 270 counterclockwise, we are turning to the left. So I'm going to do 1, 2, 3 turns to the left. And we're looking for the ordered pair for y prime. So starting from the origin to get to y after I turned it, I'm going to go right 3. Well, when you go right 3, that's a positive 3. And then I go right 3 and up 3, it is going to be at 3, 3. So that would be our ordered pair for y. Number 8 says, which of the following values makes the inequality true? Select all that apply. So the first thing I'm going to do is I'm going to change 28 fifths to a decimal by dividing. 28 divided by 5, that gets me 5.6. So I'm looking for numbers that are greater than 5.6. So we'll start with the square root of 38. So second x squared, 38. This is 6.16. Well, that is indeed greater than 5.6, so A is an option. -8 is not greater than 5.6, so that doesn't make sense. 19 divided by 3 is 6.3 repeating. It's greater than 5.6. 4.7 is not greater than 5.6. E, I'm going to type it exactly as it is written, so I'm going to do 2. Then we have the square root of 11. And that is indeed 6.6, so that's greater. 5.28 is not greater than 5.6. Number 9, where should the square root of -169 be placed on the Venn diagram? So I am going to simplify that by putting it in the calculator first. So we're going to do negative. Type it exactly as it's written. Negative is outside. Then we're going to do second x squared, 169. This is -13. Well, -13 is an integer, so it should be in the integers. Finally, we have quadrilateral KLMN is similar to quadrilateral TUVW. The side lengths are given in centimeters. Which proportion must be true? So we're matching. Y is this side here, okay? Y matches with 28. Oh, well, that's not on the same plane. They're not level, so that doesn't work. Y matches with 5. Okay, so those are from the same shape. So then does Y match with 28? Yep. Does 5 match with 22.5? Nope. 20 is on the bottom. 20 matches with 30. Yep, that works. 5 is on the same shape as 20, and 5 matches with X. Indeed, it should be C.